Something that said, I have
Okay, so
something,
go
I
ahead.
have something that says you are clear to enter a CUNY site. Please show this pass to security on your way into the building.
Okay, so
Uh,
if you got that link, I believe you're okay. If you got that link too, that's the cleared for pass. So if you
Yeah.
get that link, you should be all right too. That means you're I believe that means you're vaccinated. But but the ID they might still make you fill out that proxy click, even if you have the cleared for pass. Okay.
So the proxy link they'll give us once we go up to them?
Yes, and
Oh,
depending
okay.
on if there's a big line or not, you might have to wait in a line. You might not have to wait in a line.
Okay.
So, and I'm guessing a lot of since a lot of people, from what I understand, that Queens College has gotten access to start doing in-person classes. All the hybrid classes have been cleared to do in-person classes. So I'm just waiting confirmation from the coordinator, Dr. Look, to verify it. And once that's verified, I will let you guys know. So until I let you guys know that we're officially coming online, coming in person through the announcements page, right? Then we will still be on online. So until I send out an email to everyone, we will be online. But just know that we will soon start come to in person. So get all these other formalities out the way, such as ID card, vaccination. Okay.
How much notice will we have to know if we're coming in person?
That's a good question. I'm waiting to hear from confirmation, because I believe depending on the vaccination status on section by section, if this, let's say for example, our section doesn't have too many students that are vaccinated, right? That means we might not get the clearance, and if we do get the clearance, they'll have to figure out a way for the students who are vaccinated and unvaccinated to stay 6 feet apart. So it's just up to Queens College to decide and what the results are. But from what I understand, starting next week, well, starting October 8th, because October 7th is the deadline. Starting October 8th, all hybrid classes is authorized to come in person. But I'm just waiting for confirmation from Dr. Look to verify, because he's a coordinator of all the labs. So I'm waiting for him to verify this information with everyone.
Okay, thank you.
And once as soon as I get the information, I'll make an announcement and email you guys immediately. So you guys have enough time to know this, okay?
And when we do go in person, we only need that special lab notebook, right? Do we need anything else?
Yeah, so so that was one thing about the ID card. Second thing is, so once we start coming in person, you guys must have a pre-lab, right? And make sure you guys wear the correct attire. So long sleeve pants, no open toe shoes, and I believe, and no no contacts in lab. All right, so long pants, no open toe shoes, and no contacts in class, and pre-lab. So you must have the pre-lab. Pre-lab is first what we talked about the first day. Pre-lab is basically the procedure, right? A short introduction, so you know exactly what we're doing, but mostly it is a procedure of the lab. Okay. So you guys will go in and get out. Okay.
So we aren't submitting labs on Blackboard anymore?
That I still have to talk to Dr. Look about. Dr. Look wants, as soon as we start coming in person, I believe he wants in-person labs. So those will be, but I'll see what his flexibility is with that. Because like I had an agreement with you guys, I prefer if I give you guys until the end of the day to hand it in, but I'll see what he says, okay? But also, if he does approve that, then that means you still would have to take a picture of your pre-lab and submit that along with your report, okay? Because that pre-lab must be in your report, because that pre-lab has all your information and data you need to do the lab report.
But the pre-lab's just the procedure, right?
Yes, the pre-lab is just strictly the procedure and a short introduction if you want to write like, oh, what we're doing that day. If you would like to have that introduction, then yes.
So like the first half of the lab report that we've been doing?
Yes, basically, yes.
Okay.
So, but mostly it's the procedure, okay? You need to have the procedure written down so you know exactly what you're doing. And also, if you guys want, you could print out the PDF of the lab we're doing and bring that into if you're more comfortable, but you must have the pre-lab, okay? So you could have both the pre-lab and the written PDF file, not the written, but the PDF file of the lab manual.
Professor,
pre-lab
where is the pre-lab? Where is the pre-lab?
The pre-lab is well, you have to write the pre-lab yourself in your lab notebook.
Oh.
Where is it or what is it?
So like there is no file or anything we can print out?
No,
and
no,
then do it?
no.
Oh,
It's it's basically the procedure of that specific lab we're conducting in person. Like, so today was the osmosis, right? Today, the pre-lab would consist of what? Short introduction of what osmosis is, and basically the procedure of how to make the dilutions, right? And then what to check when you make the dilutions and everything. Okay, so just be aware, just wanted to make that announcement that be aware that we might soon start coming in lab, okay? I mean, in person to lab. No, it doesn't have to be typed. It has to be, you have to write, the pre-lab must be written in your lab notebook that the first day of the semester we talked about.
Can you
Yes, the
send a
copy.
link for the lab notebook again?
It should be up, it should be on Blackboard right now. The
Oh.
links for, it should be on Blackboard. Under manuals, it should be there. Or if anything, you could literally Google carbon notebook. And if you find one cheaper, just send me the IBN link or just the Amazon link you have. Send it to me, I'll verify it. And if it's good, then I'll let you know you could buy this book. Or if you want, you could buy the one from the bookstore. Okay, so as long as it's a carbon notebook, carbonless notebook, you're good. All right. Okay, so coming in person, talked about that, and pre-labs. Okay, so those I want to get that out the way. Any other question does anyone have? Oh, so lab 4, I believe, is due tomorrow night for you guys. Okay, it's not due tonight, but it's due tomorrow night. Okay. All right. Okay, so we'll start today's lab. Any other question before we start? And also remember, so once we start coming in person, there are no makeup labs. So if you miss a lab, I'm allowed to drop one of the lowest grades. So if you miss one lab, that lab will be given a 0. And there's no more videos, so we won't have videos for in-person labs, right? So I can't record anything. So if you miss a lab, then it's going to be a 0 once we start coming in person. Okay. And if you miss a lab due to, let's say, if any of you guys are not vaccinated, or even if you're vaccinated and you have symptoms of COVID, please stay at home, get a test done, and email me. Okay. That is the best way, because even if you have the virus, we will still be coming in person, right? If everyone is vaccinated, we'll quarantine for 3 days, get a PCR test, and we will come back if everyone is negative. But if you're sick, stay at home. But if you're not sick and you just miss a lab, then you have to. Then it's a 0.
How does it work if you were exposed? Do you also stay home or you come in?
So if you're exposed to COVID, you get a PCR test done, and if it's negative, then you're okay. But if it's not negative, then you have to quarantine, I believe, for I think if you're vaccinated, you have to quarantine for about a week, and then you're allowed to come back to campus. Depending on what the state guidelines are about vaccinated people and testing positive for COVID. Because I believe someone in my lab, his father tested positive for COVID. He was vaccinated, but he didn't even have symptoms. He works for the MTA, and they get regularly tested, and he just tested positive, but he just quarantined for about 5 days, and he was allowed to go back to work. So if you're vaccinated, then honestly, it's the best policy, because you're protecting yourself and everyone else around you, and then you don't have to go through all these 2 weeks quarantine and then get PCR tested all the time. All right. Any other questions?
Professor,
Yes.
Oh, it's not a question,
Oh.
but I heard you were taking attendance and I wasn't here because
Yeah.
I stepped out for like 5 minutes. Sorry.
Yep, I saw your text. Don't worry.
Okay, thank you.
No problem. Okay. All right. Let's start. Okay. Everyone can see the screen?
Yeah.
Okay, good. Okay. Has everyone taken a bio class? Bio 105 or 106, either one?
Yeah.
Yes.
Okay.
No, I didn't.
Okay, that's fine.
Taking one right now.
Okay. All right. So today's is Van Hoff osmosis. What is it? Van Hoff's osmosis press, right? So osmosis is the movement of particles or water, right, through a membrane, and that causes a pressure in the membrane, right? So what pressure is needed to drive this pressure needed to drive a solvent, right, through a semi-permeable membrane, right? So that is osmosis pressure, right? Our body does osmosis all the time, right? So filters are through reverse osmosis, right? Some filters are caused by reverse osmosis. So they actually use pressure to filter out some stuff. But sometimes osmosis is just the movement of solvent from one environment to another environment, right? So, and what pressure is creating, right? It's usually from higher pressure, right, to lower pressure, right? Does everyone remember that?
Yes.
Right, so because water goes where? From high concentration to what?
Low concentration.
Yes. Water moves from high to low, right? So we're basically reducing the pressure, right? If water is contained in one specific volume, too much, the pressure there is high, right? But if it goes to a lower concentration, but if it's moving away, then we're getting lower pressure, right? So osmosis usually go from high pressure to low pressure. Reverse osmosis is the opposite. We're actually increasing the pressure to make different separate solids, or like some filters are made through reverse osmosis. Let me see what Brooke said. Yes, balancing the concentration. Basically, they're trying to balance the concentration, right? Okay, so what we're doing in this one, right? We want to, so our body, if you guys all remember, right? So our body is a cell, right? Right, you have the mitochondria, we have some organelles, right? Then we have the nucleus, and the nucleus has some ribosomes, or the extra, right? So this is our membrane right here, right? This is our cell membrane, right? Cell membrane, right? The cell membrane lets in what? Without even caring. It has to be what? Our body is made 70% of what?
Water.
Yes, so water, exactly. What? So our water goes in and out the cell regularly. There is no channel that controls water. But our body is made out of electrolytes, right? Electrolytes are basically salt concentration. But the salt, right, needs to go into our body, but it cannot go through osmosis. So what we have is we have channels, right? These are specific proteins that allow big atoms to go in and out depending on concentration or depending on electrical signals. So salt can only move in and out of our cell either through an electrical signal telling the cell we need to uptake salt, or we need to let salt out of our body, or through a gradient. So if there's too much salt inside the cell, the cell will move salt out, get water in, or if there's too much salt outside, salt will come in and move water out, right? So that's how our cell works, and that's how basically what osmosis works. Okay, any questions about that? Nope, okay, good. All right, so today what we're doing is we want to check the osmosis. We want to count the I factor, right? The Van Hoff I factor is basically saying how many moles of element are actually being ionized, right? And the way we could do that is using potatoes. So we could count if there's more ions in a solution or less ions, and using that we could count how much ions are being formed. So glucose. Does anyone know the structure of glucose? 1, 2, 3, 4.
C6H12O6.
Yep, there's a lot of OHs, right? OH, 1, 2, 3, 5. And I think it's an aldehyde functional group somewhere. Let's say this is an aldehyde. 1, 2, 3, 4, 5, 6. Yeah, sorry. Delete this. Right, 1, 2, 3, 4, 5, 6. I think it's is it aldehyde? I forgot. But let's pretend it's an aldehyde, right? So this is the function of glucose, right? Glucose does not have any ions, right? Because even though these are hydroxyl groups, which you guys will learn more in organic chemistry next semester, these components do not ionize, right? So when we put glucose in water, it does not ionize. It doesn't form no ions. No ions form, right? But NaCl is a what?
Salt.
Salt.
It's salt, and it's a what compound? Is it?
Electrolyte.
It's an ionic compound, right? Because the electronegativity difference between sodium and chloride is more than 1.7, right? Right, guys? Yes, no?
Yes.
Right. So that's why it's an ionic species, because once you put in water, it ionizes. So water has a partial positive here, partial positive here. How do you calculate electron? You could just, I'm not gonna go over it now because it's not really important, but it's just the electronegativity of this compound minus the electronegativity of this compound, and you just have to look it up in the periodic table, right? And if you differentiate it, it should be greater than 1.7. 1.7 or greater. And that means that this compound is an ionic species. Okay, so in water, right, when you have this, you have chlorine atoms will bind to here, right? And sodium atoms, sorry, wrong way. Because it's partial negative, right? So sodium atoms will bind to here and chlorine atoms will bind to here. But in super concentrated samples, that's really not the case. In unconcentrated sample, that is the case where this is all the ions will separate. But in concentrated samples, Na plus Cl is actually close to more chlorines, right? And the chlorines are more close to sodium atoms. And there's also there, but we also have this interaction here. We still have this interaction here once we make a solution in a concentrated solution. So we want to check what is the I factor, right? The I factor tells us how many does this compound actually dissociate into 2 atoms, or does it dissociate into more than 2 atoms or 2 moles, right? So the I factor tells us dissociation. Okay, it tells us if this compound dissociates into 2 atoms or 3 atoms. So if a compound has MgCl2, how many moles should it actually dissolve into? If it was an ideal solution, how many moles should you get? No, look at it again.
3.
3. Why? Because there's 2 chlorines, right? 2 chlorine minus. Right? MgCl2, right? So you get 2 chlorine minus plus 1 magnesium, right? So that's why in the ideal solution, you get 3 atoms. But we know that in concentrated samples, it might not be true because this magnesium can also react with more chlorines. Yes, dissociate basically means to break into pieces. Yes. Okay, so what we're calculating today is basically this. Does our solution, the solutions we make, does the NaCl actually break up into all those? Break up exactly into 2 compounds? Or does it not break up into 2 compounds? And that's what we're calculating today. And that's what this lab is. Because we could take glucose. We know if 1 mole of glucose gives us this concentration, right? Then this concentration also has to equal to this, means it also has to equal to the same thing for sodium chloride in the same concentration, right? So the lab, sorry, let's go to another page. So we're talking about a hypertonic solution, right? Hypertonic is what, guys? If something is hypertonic, is there more is this
A
more
higher concentration?
More solution.
yes, this is water. Yes, is it more solution inside or outside?
Inside.
Inside, right? And if something is more hypotonic, is so hypotonic. There's less solution inside or outside?
Outside.
Less solution
Outside.
inside.
Less solution. So let's go this.
Inside.
Hypertonic is what? More water outside or inside?
Inside?
Inside.
Yes, more water inside. And hypotonic is more water
Outside.
outside. Outside. So that means water, if there's more water outside, right? Let me just double check. Even I get confused when it comes to hypertonic and hypotonic. Hyper means
Other way around.
let me just make sure I'm telling you guys the right information. A hypertonic solution, water flows out from the cells. So a hypertonic solution means there's more water. There's more water inside, yes. And hypotonic means there's more water outside. So if there's more water inside, then water will flow out of a hypertonic solution, right? So water flows out. And if it's hypotonic, water flows what? In. Good. Okay. And then isotonic is when something is what? Balanced, correct. Balance, right? So these are the 3 type of osmosis that a cell could have, any living cell. A potato is a living cell, right? So that's why we're using potatoes if we did this experiment. All right. So
Is isotonic another word for equilibrium?
okay, so equilibrium. Sometimes you could use isotonic for equilibrium, but isotonic mostly refers to when osmosis. Okay, so you can't really use isotonic if you're referring to a chemical equation, but if you're referring to osmosis, then you could refer it to as isotonic or equilibrium. Does it help?
Yes, I understand.
All right, cool. Okay, so today's lab, right? We're making cells, right? So we did this. Sorry. So we talked about this. does not want to, okay. Y does not want to, okay. We talked about the first paragraph, and then we talked about, come on, move. Come on, bro. Move. Oh, there you go. Okay, good, perfect. Okay, so we talked about osmotic pressure, semi-permeable membranes, and then so talking about the graph itself, right? So we want to check if a compound actually gain water or let water out, right? And this is where fractional mass change comes in, right? Fractional mass change is telling us how much percentage of the mass change. So did the mass increase or decrease, right? So to calculate fractional mass change is we use this equation, right? So fractional mass change. So when we do this,
Professor,
yes,
are you writing anything on the board?
yes,
We
We
don't
can't
see
see it.
that
not on the whiteboard, but like on the PDF. Can you see it? I'm scribbling.
on this PDF. Are you sharing the screen? Because
Oh no, I'm not sharing the screen. Thank you guys. Not sharing the screen. Oh. Can you guys see it now? The scribbles?
Yes.
Okay, great. Okay. Okay, so fractional mass change, right, is basically saying if the potato we have, did it gain or lose mass, right? So if something gained mass, that means water is moving in, right? And if something lost mass, that means water is moving out, right? And to calculate that, we use fractional mass change, right? So we don't actually want to calculate if it gained or lost. We just want to see how much was the gain or the loss, okay? So everyone knows, any questions on that? No questions? Okay, so fractional mass change is this equation right here. So it's final mass, right? Just make it right. So it's the final mass minus the initial mass divided by initial mass. Initial fractional FMC, fractional mass change. Okay. All right. Now to calculate the Van Hoff I factor, right? So basically I said that we know that if 1 mole of glucose gives us this solution when the compound is isotonic, so it should also give us the same for a compound with such as NaCl or magnesium chloride or magnesium sulfate in the same isotonic solution, right? And we could calculate the Van Hoff I factor, all right? And the Van Hoff I factor is basically taking the concentration of the isotonic of glucose divided by the concentration of the salt in its isotonic, dividing that, and we get the I value. Okay. Any questions? So it's the isotonic. So it's the isotonic NaCl over the isotonic glucose. Isotonic glucose divided by isotonic NaCl. Okay? And that's how we get the Van Hoff I factor. Any questions? So this is a calculation you guys would make after you have done the graphs and everything. So on Blackboard, you guys see the two PDFs I uploaded, right? One of with the information you guys will need, and the other one is Well, one is the data set you should use, and the other one is the information you guys need. Everyone, can everyone see that on Blackboard?
Checking right now.
Okay. Just let me know if you guys see it or not, please.
We see it.
Ah, perfect. Okay. Cool. All right. So continuing. So first thing we'll do is we're making solutions, right? So we want to know we want to calculate the concentration of the solutions. So who remembers that equation we used last time to concentrate solution? So we have glucose. Oops, the glucose wrong. Glucose, and then we have NaCl, right? So on the table, what is the concentration of our glucose? What does it say? Our stock solution concentration. So
Glucose?
if you, yeah, the glucose, if you open up the Van Hoff osmosis data, it tells you on the bottom the concentration of our stock solutions. Yes, 1 molar for glucose, and for NaCl is what? 0.5. Good. 0.5 molarity, right? So now we want to use this to calculate our concentration, right? So we have 6 concentrations to calculate. So these are the calculations you guys will have to do. I'm not going to do these calculations because you guys should know, so I'm just going to assign people to do it. Okay? So I'll give you a little hint. The equation we're using is M1 V1, right? So we have 6 test tubes. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The first one, the concentration is going to be 0. Can anyone tell me why? Because what are we just putting in number 1? Is what?
Water.
Yeah, just water. So there's no concentration. We're not putting glucose in our first test tube or NaCl in our first test tube. Okay? So from there on, you guys will have to do the calculations. So I'll pick, 5, 10 of you guys and just do the calculations. Okay? 1 second, guys. Eliza, are you here?
Yeah.
Cool. So you'll do glucose, 10 milliliters of stock solution, okay?
Okay.
So let me give everybody, then you can start. So Ashley, you there?
Yes.
Cool. Glucose, 20 milliliters. Brooke,
Hey, pass.
glucose, 30 milliliters.
Okay, got it.
Christine, glucose, 40 milliliters.
Which one? 4?
40 milliliters for
40?
glucose.
All right.
And Cindy,
Yes.
you'll do glucose, 50 milliliters. So you guys can write on this yourself. So if you go to annotate if you go to annotate, then you guys could write directly here. So just tell me the final concentration once you do just tell me the M2, M1 equals M2 V2. Okay, so just put the final concentration, okay? sorry, that's 10. So that's 10, 20, 30, 40, 50.
Professor, just to confirm, you said I was 40, right? For Cindy?
Cindy, yep, Cindy, you're 50.
Oh, 50. Okay, thank you.
So just tell me the M2, okay? And everyone, you guys know how to calculate this, right? So if you guys have any questions after your classmates calculated it, just speak up. And so for the sodium, Jasmine, you will do sodium chloride 10 milliliters. Jason, so sodium chloride 20 milliliters. Lakshita, sodium chloride 30 milliliters. Malaika, sodium chloride 40 milliliters. And Matthew, sodium chloride 50 milliliters. Okay. So once you found the concentrations, you can just put it next to your respective test tubes.
Wait, sorry, Professor. Did you say I'm 20? It's Jason.
Jason, you are 20, correct?
Okay, thank you.
Yep.
If we weren't assigned anything, do we just wait?
Well, you guys could. Well, you know, you guys could do the calculation to see if they're correct too. Okay.
Okay.
I'm a
If they give you
little.
the,
Oh, sorry.
no, go ahead.
I'm a little bit confused. At M1, we use the value given to us on the data sheet.
Yeah. So M1, it's Matthew. You have 50 milliliters, right? So your M1, you're doing sodium chloride, right? So your concentration of M1 is 0.5, right?
Yeah.
So your volume 1 is 50 milliliters. Your volume 2 is 100 milliliters. And then you just have to calculate your M2.
Oh yeah. Okay. I got it.
Okay. So once you guys done, just write it next to the M2 numbers you guys have. Okay.
Where did you get the second volume from?
Which second value?
The volume.
The volume 2. So if you look in the procedure, volume 2, it says we're adding up to 100 milliliters.
Okay, got it.
All right. So what do you need? 5 minutes to do this?
Wait, so for V2, do you subtract 100 from that first?
No subtraction. No subtraction. Just rearrange this equation to do the M2. You don't need to subtract it, okay?
Did you give them the same data that you assigned in the for the actual lab?
No, these are the same data. No, these are just I just randomly made it right now.
All right.
Okay, so we have 1.
I'm confused where I'm supposed to get V2 from.
Oh, V2 is on that's the same question Matthew asked. If you look in the procedure, it says we're increasing the volume to 100 milliliters. So volume 2 is 100 milliliters. Okay, so give me 1 second, guys. So if you look over here, right, our final volume for all the test tubes is this. It's 100 milliliters. Right, so because these are our initial volumes, right? Initial. And the final volume for all of them is this.
Oh, I got it. Thank you.
Yep. Okay, so I think somebody already did the thing. Yes, initial is what I told you, correct.
So for the student data, I think there's 1, 2, 3, 4, 5, 6. There are 6 points for each of them for both the NaCl and I forgot what the other one was. But check.
Did it get deleted?
And for the glucose, so are we doing N1V1 for all 6 points for each of them?
Yeah. Wait, I think the thing got deleted. Okay, well, you guys. Okay, it got deleted, but let me just write it again. So, glucose and NaCl. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is 0. This is 0. So M, this is 10, 20, 40, 50. All right, so you guys see how Jason put his concentration? You guys could put it on the screen just like that, okay? So all you have to go to is annotate and just put it right next to how Jason did it.
Where is annotate?
So if you're on the if you're on the computer, it's the
Yeah.
little bar on top, and it says it has the drop down menu, like 3, like
Oh, view options. Okay, thank you.
yes, yep, and then it says something with annotate. Okay, and then you could use that to write right next to your thing. Yep, there you guys go. Go ahead, guys. It won't let you draw. Okay, Eliza. Then just put in the group chat, Eliza. Go ahead.
Professor, I have a question.
Yeah, go ahead.
This is just like an example, right, that we're doing?
No, this is exactly what you have to. These are exact answers for the lab.
Oh, I see it. Yeah, it's on the lab menu. I got it.
Professor, I don't know. What do I have to click again to annotate? Because
Okay, so are you are you using like a laptop or a desktop or anything that's not an iPad?
yeah.
Okay, so on top, right, it has this little bar and it has 3 dots.
Okay.
And if you press those 3 dots, right, it gives you a drop down menu, and in the drop down menu it says annotate.
Oh, I got it.
There you go.
Thank you.
We're waiting for Lakshita. And okay, Brooke is writing his right now. Are you gonna write it down or should I write it for you, Eliza?
Are you able to?
Okay, go ahead. You wrote? I can't see it.
I'll write it again.
Oh, are you typing it or are you putting into the?
I put it into the group.
Oh, okay, so I got it. So it's 0.1. Okay. I'm waiting for Jasmine. So Lakshita, what is your number you got? Okay, that's fine. Just tell me what you got. I'll write it for you, Lakshita. Yep, correct. And Jasmine, what did you get? Correct. Good. Good job, guys. Okay, so these are the concentrations of, and these are actually the correct concentrations of all the solutions. Does anyone have any questions on how your classmates receive this? Because you will have to show this concentration. You guys know the concentrations, and these are the correct concentrations. So you guys will just have to show it. So what I would suggest is just do one M1V1 equals M2V2. Just show it one time, right? And then you could just show the calculation one time, and then you could just put, this is the calculation that results to all these others. Okay? You guys don't really have to show all the calculations all the time, because then since we did it together, I know you guys will have the right answers. All right, so just show it one time and that's it. And then just put the concentration for the rest. All right? Sorry, I can't hear you.
Can you hear me now?
Yeah, go ahead.
Yeah, so I see that you put like our names and table numbers, like for me, 3 and 16.
Yes.
So how will it work then? Like,
Well, so the concentrations are the same no matter what table you have. So that table will be used when you actually have to graph this information, which I'll show you guys in a little bit. Okay?
oh, okay.
All right. Does anyone have any questions? Any questions about this calculation? Because these are the correct calculations. These are all correct.
So we don't have to do this on our own. Like
Just show it one time for glucose and NaCl, and that's fine. And then you could just put the concentrations for the rest. Okay, you don't have to do 6 different calculations all at once showing me. You got, so like this, look, so in your paper when you do it, right, so just show one time, right, you could say, oh, glucose, right, 1.0 m. So don't do 1 because 1 is 0, so you could start from test tube 2, right, test tube 2. So you could just show m1 v1 equals m2 v2. M1 was was 10, right, sorry, it's 1, it's 1. And V1 was 10. M2 is, we know, and V2 is 100, right? So M2 equals 10 divided by 100, right? Equals 0.1, right? And then once you show this calculation, you don't have to show it, repeat it again 4 more times. You could just show same calculation. So for 30 milliliters, so that was 10, so this was 20, 30, 40, and 50. You could just say M2 equals that. Okay, so you don't have to repeat it 5 other times. You guys understand what I'm saying, right? Or no?
So are you saying that we have 6 cups and then like the first one is just the stock solution? So we just do the stock solution and then the other 5, like we don't have to do the calculations for them?
Yeah, so test tube 1 is 0 because that's just water, right? So for test tube 2 is where we do the calculation for the different concentrations. So you could just show the calculation for test tube 2 for glucose and sodium chloride, and then you don't really have to show all the other calculation because it's the same formula you're using. So you could just put the numbers you saw that your classmates put down after the second, after you show the calculation for test tube 2.
So should we disregard the data that you gave us?
No. That data will be used when we do the graphing. This is just for the concentrations, because this.
Oh, all right, got it.
Okay. Everyone understands, right? Or no? And if you want to show the calculation 6 times, then go ahead. That's good too. Or you could just do it.
Do we have to do one calculation for each, like one for glucose, one for NaCl?
Yes, just show one for glucose, one for NaCl. Yes, you're correct. Right, and if you want to show all the calculation, that's fine too. I don't have a problem with that. Okay, but you have to show the calculation at least once for glucose and sodium chloride. Everyone okay with that? Or is anyone still confused? Because you still need this when you make the graph. You need these concentrations when you make the graph. Okay. Good. All right. So now we have the concentration, right? So now everyone should have the data open. So any question about concentration? Let me go back to this page. So everyone has these concentrations because these are the same concentrations for everybody. What changes is the other data that I gave you, the mass of the potatoes. Those are not the same, but these concentrations are the same for everyone. Everyone good? Everyone okay? Any questions? Because if you guys email me saying how to calculate the concentrations, I'm going to tell you one thing. Look at the video. So if you're confused, ask me now, guys. All right, perfect. All right, good. Okay. Okay, so now everyone has a data set, right? So I'm gonna, 1 second. Oh, good. So now I'm gonna show you guys how to do the data set. Can everyone see this?
Yes.
Yeah.
Yes.
So this is exactly what you will have to add to the data set. So if you guys look at it, right? So I picked 2 random ones and I did it. This took me at most maybe 10 minutes to do. So if you're good with Excel, this will take you at most 10 to 20 minutes. But if you're not good with Excel, that's fine. I could show you guys how to do this using your okay. So if you're not good with Excel, I'll show you guys how to do this. But if you're good with Excel, if you're good with Excel, then this lab will be literally done for you in maybe in 2-3 hours, right? But if you're not good with Excel, then you have to calculate some of these information hand-wise, which is also fine. Because when I took this lab about 7 years ago, I wasn't good at Excel, so I did it hand-wise. But as you have to be good in Excel to to apply for better jobs or stuff like that. But okay. So I took. Let me show. 1 second, sorry guys. So I took the data set from sodium chloride table 5 and I took so I'll go one by one. So the first data set I did was sodium chloride 5, right? Can everyone see the manual, right? So the manual tells you how to set it up exactly like this, right? And the manual tells you cup A, initial mass, final mass, molarity, FMC, which is fractional mass change. So that's basically how I set it up, right? I have my cup number, I have my initial, I have my final, I have molarity, and I have FMC, right? Cup number 1, 2, 3, 4, 5, 6. Then I have the initial mass, final mass, molarity, and FMC. So the molarities are exactly what we calculated, right? So molarity was exactly what we calculated. And then this initial and final mass is what you would get from the data set that I gave to you guys, right? So, okay. So you guys see the data set, right? So data set, I chose table 5, right? It gives me the initial mass and the final mass of the potatoes after it was submerged in the sodium chloride. And table 20 and table 24, right? when the potato was submerged in the glucose, and these were the initial mass of the potatoes and the final mass of potatoes after submersion. Okay. Any question about the data set so far? Everyone is good.
Yeah.
All right, perfect. Okay, good. So I'm gonna skip this data set. We're not gonna go back to it. So we're gonna focus on the Excel. So I put the initial mass and the final mass here, right? I put the molarity. These are all stuff we calculated already, and the initial mass and final mass was given to you. So now I want to calculate the FMC, right? Fractional management, you could calculate it two ways, right? You could actually use Excel to calculate it for you, or you could do it hand-wise, right? If you do it hand-wise, remember what it was. It was the final mass, right? Can anyone see me right or no?
No, we can't see.
Oh, can't see you right now. No.
Okay, give me 1 second, guys.
Oh, it showed up.
Now it
It
says
showed up?
final. Yeah.
Okay, good. So final. So take the final mass.
No, can't see again.
Oh no, I'm not writing. So the final minus initial. Give it some time, it'll come up. It's a little bit slow. Minus initial. You guys see that? So that's
Yeah.
FMC,
Yeah.
right? So this is how you would calculate with your hand. So what you would take, so for cup 1, right? So for cup 1, you'll take your initial. So you'll take your final mass, 1.264 minus 1.126 divided by 1.126. And this is the number you get, 0.1225577. Or, right, so you would do this for all of the cups, right? If you want to do it by hand. If you want to do it by hand, then you have to show me the calculations, right? But if you want to do it by Excel, it's actually pretty cool. Look, right? So Excel, it tells you exactly what to do. So to calculate the FMC for you, you would put the equal sign, right? Then you put parentheses. So then you take C2, right? C2 is our mass right here, minus B2, the number here, which is our initial mass, divided parentheses, and then you divide that by B2, right? And then you get and it will calculate the FMC. So once you get the FMC, right, you just have to drag it down. So let me show you guys real quick. So this is what I did. I didn't want to actually put all this in all the time, so I did it one time, right? So let me show you how I got it. I'm gonna delete all this for you guys right now. So I deleted everything, right? Everyone see that I deleted everything, right?
Mm-hmm.
Because all the other numbers we know, because I either gave it to you or we just did it in the lab, correct?
Yes.
Right. So if you go back to the lab manual, right? Right. All I did was just calculate the command. So in E2, in cell E2, enter the formula this. So all I did was just copy, right? Paste it in E2, paste, and it gave me this. And all I do was just drag this down. And it gives me all these numbers again. And that's it.
Wait, how did you do that again? Where did you get the first number again? The one that.
So do you know how to calculate it by hand, right?
This is this is the fraction, right?
Yes, the FMC, fractional mass change. So you know how to calculate it by hand, right, Matthew?
Yes.
Okay, so you want to know how to do it on the computer.
Yeah, absolutely.
So let's delete all this. I'm gonna delete it again. So you could do it two ways. You could actually put in the command that you could either put in the command manually. So you could put this in on E2, like so it says in cell E2, enter this formula. You could enter this formula in cell E2, or what I just did was just copy this, basically the same, and pasted it in cell E2.
Oh, I understand. Oh,
right, and I pasted this, and it gives me this, and this is the same. So And this is the same number you would get if you did a hand. So all I do is just drag. I pick this corner right here and I drag it down, right? And it will do the calculations for me for all of them. This is not the isotonic. No, the isotonic is coming up a little bit, but this is just the FMC. Yes, that's FMC, yes. So any questions about that?
So you just basically copy and paste, and that's it, and drag
Basically,
it down.
yes,
Okay.
very simple. Copy, paste, drag down. So if you guys want to write this down, copy, paste, drag down. And make sure you copy it in the right section, in the right cell, because it has to be in cell E2, okay? You don't want to put it in any other cell. All right, so, and that's the same thing you'll put for, so if you want to do this, you could do it either, so what you could either do it separately, or you could do it together like I did here, right? So if you do it together like I did, it's a little bit more complicated because you have to change just the cell number. The equations are the same, but just cell number. So I'll show you. So it's the same equation, right? So all I did, so I'm gonna show you guys how I did this, right? So I'm gonna delete all this, right? So you guys know how to calculate the FMC, right? So this is glucose now. So we did sodium chloride, but now we're doing glucose. FMC is the same calculation. Initial, the final minus initial divided by initial. What is that number next? Which number? This? Oh no, this is just a table set that I use. I use the 24. That's a table I use for glucose. Okay. Okay, so now the equation is basically the same. So I go back to my little thing, copy. Copy. And I want to paste it here. But what's different, guys? What's different from here? From here and here? What is different? Why can I not use the same C2, B2 divided by B2?
The cell
Good.
number needs to be different.
Yeah, you're at
Exactly.
16.
Exactly. Perfect. Who's at 16?
Brooke.
Good. 16. So we initially, so it's our final, right? So our final, we start from C16, right? Minus what? B what? Somebody tell me.
16.
Yes. Minus B16 divided by? Divided by what,
B16.
guys?
B16.
Perfect. Yep, 16. You press enter. Then the same rules apply. You drag it down. And then you get your numbers. Bada bing, bada boom. And you save yourself billions of calculations. You could do it hand too. If you're not good with doing this way, it's totally fine. What are you confused about? Oh, so I got 16 because our cell 16 right here. You see 16? So I can't really use B2 because these numbers are not in B2 no more. We start with cell 16, right? The column C, but we start with row 16 when we're doing these calculations. Okay, because C2, B2 is just referring to what column and what row. So I'm using column C, row 16, minus column B, row 16, divided by column B, row 16. And these are just those numbers that are in those specific columns. So it's telling me take the number in column C, row 16, divide that by the number in column B, row 16, divided by the column B16, and then you drag it down, yes. And it does the equations for that, okay? Any questions about how I did that? It's basically the same step for both, okay? Just the only thing that's changing are the numbers are changing because the molarity is changing and the initial and final mass are changing. But the steps are the same to get these FMC calculations. And if you're not good with this, then you could always handwrite it and show me how you did it. Just like I said with the thing, just show me the calculation once and then just give me the numbers for the rest. Okay, but if you want to do it this way, then you could do it this way, but you would have to, when you do it, post this information on your post this information on your report so I can see that you guys did these calculations. Okay, so all you have to do is just, copy and paste this information. Or you could just take a screenshot on your computer and just paste it onto your report so I can see that you did it using Excel. All right, so now how do we calculate?
Wait,
ahead.
so what do we copy and paste if we did the
if you-
calculations using Excel?
Yeah, just you can just copy and paste all these cells right here, right? So copy this, right? And then you could, give me 1 second. Right? Right, and you can just paste it.
Would we just put in the data section of the report?
Yes, you put it in data section, yes. Oh, I'll get to the isotonic value right now, if this wanna let me. Okay, there you go. Paste. And this is what information you would display on your lab report. Okay? Everyone okay with that? Because I have to see this information on the lab report. I won't just, take your word for it. You have to show me, just copy and paste this there and you're good to go. Okay, now, so we have all this, and now let's go to the isotonic value. So now let's go back to the lab manual. So the lab manual just tells us how to calculate that. So isotonic value. So isotonic value is when the x-axis cross, when we get 0 for the x. So if you guys remember, give me 1 second. So if you guys remember, how do we get we have y equals mx plus b, right? How do we know at what number does the x value crosses the plane? We set this to 0, right? Set this to 0, and then we do mx plus b, plus b, plus b, mx equals b. Sorry, this is minus. Minus b, and we divide it by m. We divide it by m, x. And then we get minus b over m. So this will give us at what intercept the x-axis equals 0. Okay? And this is what the isotonic value is. If you want to do it manually. So this is the equation you'll use. All right, so if you don't want to use Excel. Isotonic value. Okay? At what position does x equal 0? And this is how you would solve for it. All right, any questions? No? Okay. Where it is. Okay, so now Excel actually could calculate the isotonic value for us, right? So how it tells us, the way it tells us to do this. So first in cell A9, right? So let's go to A9. So we have cell A9, right? So let me delete this so you guys. So we start from the beginning, right? So cell A9, I put isotonic, right? I wrote isotonic. And now all I'm gonna do is just copy and paste the equation it tells me to use. Like basically, so like last time. So just copy this equation. Copy. Paste. And that's the isotonic value for this graph. Okay, and I'll show you how to do the graph. Okay, and so same thing with this. Remember, so the equation that I copied, right? So the equation I copied. Let's delete this, right? Right. So the equation I copied, I can't use the same equation, right? Because we're not using this data, we're using this data, right? So what should these numbers be? So over here, I'm using D2 to D7, right? And I'm using E2 to E7, right? So what should it be over here? So it should be what? D what? Anyone?
Is it 16 to 22?
Perfect. D16 to D22. And then what should it be? E what?
E17 to 21?
Not 17,
Oh, E16 to 21?
not 21,
22.
22. Correct. Press enter, and then we get that same number. And this is if you want to do this on the same Excel folder. If you don't want to, you could do it separately, and then the equations, you don't really have to manipulate the equations like how I did. But if you want to do it like this, then that's how you would do it. Okay? So now that we have this, right? We know the isotonic value for our glucose and our NaCl. And to find the I value, what is the equation? What was the equation, guys?
Isotonic glucose over isotonic sodium chloride.
So what is the answer? So isotonic glucose, let's say is 0.325 divided by
0.21763.
217. So there was a value?
1.
Let's say 1.5.
Mhm.
Right? So the I value for these two are 1.5. So sodium chloride. So remember we said sodium chloride should theoretically go to 2, right? Because it's two compounds, right? Sodium and chloride. It should go to, when you put it in water, it should really go to 2 moles, but it doesn't. It goes to 1.5. And why does it go to 1.5? As I described earlier, because sometimes the sodium can interact with the chlorine in solution. So it doesn't really give you 2 moles, it gives you 1.5. Okay, everyone, so that's the lab. So let me show you the graphing. So I'm gonna delete this graph, right? Delete this and delete this. So we're gonna graph molarity and FMC, right? Molarity is on our x-axis and FMC is on our y-axis, right? Okay, so you would select this, go to insert, scatter, right? You get this, and then you could quick layout. You put this, right? So this here is our sodium chloride, NaCl. Our x-axis is molarity. Our y-axis is FMC. And then we just add trend line. We want to add a linear trend line, right? And then we add display the R equation and display R squared. Move it up over here to be clearly viewed. And then if you want, you could add the data labels. If you don't have to really add the data label, if you want, you could add it, right? And so if you want to calculate the isotonic value yourself, right, you would have to use this Y equation, right? So if we take this Y equation, if you solve for it, we should get the same number or around the same number of 2.17. So let's see. So this number is, so if you do the equation, so if you do the equation, right? So it's Y equals minus 0.52, let's just round it, X plus 0.12, right? So we want to solve, so what happened? X plus 0.1. 2, right? So you want to set this to 0 equals negative 0. Okay, this is acting weird. Sorry, guys. Give me 1 second. So our equation was y equals negative 0.52x plus 0.12. Just rounding off the numbers, right? So we want to set this equal to 0 equals negative 0.52x plus 0.12 minus 0.12 negative 0.2. Right? Equals negative 0.52x. Divide that 0.52. 0.52x equals 0.23. So very close to what we have, 0.217, 0.23. So this is how you would do it if you guys can't, if you guys don't know how to calculate this using Excel. So you have to, if you want to do it by hand, this is how you would get it. First, you would make the graph. You would get the linear trend line, the equation of the linear trend line, and using that, you'll get our isotonic value. So this is our isotonic value. Okay, any questions? Okay, no questions, good. All right.
Wait, what value did it plug in?
What do you mean, for what?
Like, what did you get the 0 from? Is that from the initial?
No, that's, so when you solve, so if you guys remember from algebra, when you want to solve for where x goes through the 0, you have to set y equals to 0 to solve for when x equals 0. Remember? To get the x-intercept, you have to set y equals to 0. And if you want to get the y-intercept, you want to set x equals to 0. So that's the equation, that's the relationship we use to get the x-intercept. And that x-intercept is what our isotonic value is.
Oh yeah, I got it.
Okay. Any questions?
No, no questions.
I have a question. How did you get the I 1.5 on the graph again? Because I missed that part, but I wanted to wait till you were finished.
The 1. Where did I get 1.5? Oh, the I1. Oh, so the I 1.5. So the I value is, so the, where did it go? Let's go back. So the I equals 0 is equal to the isotonic value of glucose divided by the isotonic value of sodium chloride. And if you see it, so the isotonic value of glucose is 0.325, just rounding it off, and the isotonic value of NaCl is 0.218, right? And if you give it, it equals 1.5, or roughly 1.5.
And the isotonic value is the exit intercept, right?
Yes, correct. Yep. So the I value is 1.5. So if you get anything above 2, then you're wrong. Why? Because NaCl can only go to 2 compounds, sodium and chlorine. So if you get a number that's above 2, then you did something wrong somewhere. So it should be 2 or less.
You said the I value has to be 2 or less?
Yes. Because why? Because sodium chloride can only can dissociate into only 2 ions, right? Sodium and chloride, right? If you have a compound that's, let's say, magnesium chloride, right? This can decompose into 3 compounds, right? So the I value has to be 3 for this compound. Has to be the maximum, has to be 3 in a real world situation. Let's say, and if you have a salt that contains many chlorines, it's just how many it could dissociate into. All right, so let's say example, let's say you have sodium bromide. What's the I value? What's the I value of this? The highest I value of sodium bromide should be what?
2.
2, yeah, because it can only form into 2 ions, sodium and bromide. So I value for this should be 2. All right, so that's why I'm saying for sodium chloride, if you get an I value of more than 2, then your calculation or somewhere in your graphing is off. Okay, so any questions? No question? Okay, so I'll show you guys. No, so the next one is the same graphing. So if your I value is greater than 2, then your calculation somewhere is incorrect. It cannot be greater than 2 because sodium chloride only dissociates into 2 ions, sodium and chlorine, right? So your I value has to be 2 or less. So you can see here in this calculation is 1.5. It's 1.5 because in the earlier I explained that if you have a concentrated solution of sodium chloride, sometimes the sodium is also interacting with the chlorine, so it's not dissociating fully. That's why you have 1.5. So there's still some minor interaction between sodium and chlorine. All right, any questions, guys? Please ask now, because it's fine. We're not rushing or anything. Okay, good. So now I'll show you guys how to do graphing for so this one was sodium. So this was NaCl, right? So you do the same concept. Same thing for glucose, right? So you choose this. So before you could put it into one. This one you have to be separate graphs. You can't put both of them in the same graph, right? So you go to insert, scatter, right? Right, and then you go to a quick layout. You press this. This is your glucose. Glucose. So FMC does not have a unit, so that's why it's unitless. FMC. Right, then you go add trend line, display R squared. And then if you want, you could add your data labels. All right, and this is the graph for glucose, and this is how you would make the graph. And if you want to calculate the isotonic, if you want to do it by hand, you would take this equation right here, right? So the equation is so this is for glucose. So it's y equals negative 0.28. So I'm just rounding off the numbers for now. 0.09. Set this to y equals negative 0.28x plus 0.09. Solve. X equals 0.09 equals 0.32, which is exactly the number that we get, right? 0.325. Okay, and this is our isotonic value. If you want to calculate manually, isotonic value for glucose. Okay. And so, yeah, so that's about it. So you have to include all this data and then the two graphs, and then, yeah, and then calculate the I value for your data that you have. Okay. Any questions, guys?
I have a question. Do you
Yeah.
mind showing, based on the data from your Excel, on how you calculated the molarity?
No, the molarity we calculated, right?
So from the first part of the class, that's what we put in the data?
For the molarity?
Yeah.
Yeah, that's the same numbers. Yeah, I calculated beforehand from you guys, so to make these graphs, but that's the same exact molarity we use.
Okay, thank you.
Yep, it's the same, yes. And then initial mass and final mass is in the PDF that I uploaded on Blackboard. And if you guys don't want to, and if you guys don't feel comfortable doing this, it's fine. I showed you guys how to calculate the FMC by hand, right? You could do it by hand for just one of them, one of your test tubes, and then just put the numbers in for the rest. You don't have to show all the calculations on your report. Just show one of the calculations, and that's good. And then I showed you guys how to do the isotonic value, how to calculate the isotonic value. If you don't want to use Excel, that's totally fine. I showed you guys how to do the isotonic value calculation using the equation provided from the graph. And then the I value is basically taking the isotonic value of glucose divided by the isotonic value of sodium chloride, and that's your I value. And your I value cannot be over what number?
2.
2.
Yeah.
Good. So if you guys anything get above 2, then there's something wrong somewhere.
Professor,
Okay, so yeah, go ahead.
how would you like what we will do on the lab report? Like, what should we write about?
Basically everything today. And well, everything, well, it's like you guys written about before, you know, what does the I value mean? In the introduction, you can talk about semi-permeable membrane, osmosis, pressure, you know, how we're calculating the I value, what does I value mean? For if a compound is not, for sodium chloride, the highest I value is 2, and it can't be over 2 because why? It only dissociates into two atoms, and but we don't usually get exactly 2 because there's some in higher concentration. There is always some interaction between the ions, and instead of water. There's a lot of things you have to talk about in the introduction, but the data is what we did today. I need to see all this in the data, okay? And like I said, if you're doing the molarity calculation, just show the M1V1 equals M2V2 just once for glucose and once for sodium chloride, and just put the numbers in for the others because we did that today. And if you guys want to do it by hand, the FMC calculation, just show it once and then put the numbers for the rest for both glucose and sodium chloride. But if you just want to use Excel, that's totally fine with me. Just make sure you put all this information, make sure you copy and paste this information onto your Word document so I can see it. And then also the I-value calculation and the graphs. Okay, so that's basically what you guys have to do for this lab report. Anyone has any questions about anything? And like I said, for the people who came in late, we will soon find out that we might be coming in person to lab. So make sure you guys all have your IDs and you guys have are validated for vaccination, or if you have the exemption, your exemption was processed. Okay. Yes, there's no lab due tonight. It's gonna be lab 4 will be due tomorrow night, midnight. Yeah, so make sure you guys have all the your vaccination information updated, and I'll let you guys, as soon as I find out confirmation from the lab coordinator, Dr. Look, I will email you guys right away telling, hey, we're gonna start coming in-person labs starting next week or whenever the date is, we're gonna start coming. But just know that we're soon gonna start coming in person. Okay, and when we do, just make sure you guys have the pre-lab ready for those specific days that we're coming in person. Okay, so if no other questions, you guys are free to go.
Bye, Professor.
Building are we in?
Thank you so much, Professor.
Although everybody's talking at the same time. All right, everyone who's saying good night, guys. And
What building
someone
are we in?
Oh, so if you so what building? That's a good question.